For this triangle proofs video, we are going to talk about proofs using CPCTC. And if you remember from the beginning of this unit, CPCTC stands for corresponding parts of congruent triangles are congruent. So this is, we use when we're asked to prove that parts are congruent. But in order to do that, you first have to prove the triangles are congruent. So in our previous proofs, we've always stopped with the reason, side, 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 side angle, side, hypotenuse, leg, etc. So now it's kind of like adding one more step to the proof to show that whatever wasn't previously marked as congruent can now be shown to be congruent. So, for example, we'll mark what's given. So side AB is congruent to AD. Side BC is congruent to side CD. And then we can always mark so that would be side AC is congruent to itself. So right now, if you just look at this triangle, all we have are information about the sides. And that's enough to show that the triangles are congruent. Then we take it one step further and say, well, because these triangles are congruent, then all the rest of the parts, so that would be the angles, are also congruent. So we'll start with what's given. AB is congruent to AD. BC is congruent to CD. And adding in AC is congruent to itself by the reflexive property. And then that's enough to prove that the triangles are congruent. We have side, side, side. So we're going to state that the triangles are congruent. So triangle ABC is congruent to triangle ADC by side, side, side. And so since corresponding parts of congruent triangles are congruent, we have two congruent triangles. So that means not only are all the sides congruent, all the angles are congruent. So angle BCA, this angle right here, will be congruent to angle DCA, that angle right there. And the reason for that is CPCTC. So that's what we use if we want to go one step further and show that previously unmarked parts of two triangles are congruent. So let's try one more example. So example 2. First of all, we're given that side PS is parallel to side QR. So that should already make you start thinking about alternate interior angles or corresponding angles that you can mark. And then angle QPS, remember when you name an angle with 3 letters, the arc will go at the vertex, which is the middle letter. Angle SRQ, those are congruent. Okay. So before we do anything else, let's put in what's given. So PS is parallel to QR. Angle QPS is congruent to angle SRQ. And then we obviously need a lot more information to show these triangles are congruent. So we'll look for a shared side. we can mark that. And also going back to these parallel sides. So if these sides are parallel, sometimes it helps again to take a highlighter or your pencil, make that bigger. So those would be your parallel sides. That means QS acts like a transversal. So you can mark a pair of alternate interior angles. So angle RQS would be congruent to angle PSQ, because those are alternate interior angles. And then we also have that side QS is congruent to side QS, reflexive property. Then again, we have to remember that before we can do any parts that are congruent, we have to show the triangles are congruent. So triangle PSQ is congruent, so PSQ is congruent to RQS. And this is by angle, angle, side. And then, since these triangles are congruent, then all the other parts previously not marked can also be marked as congruent. So that allows us to say that, yep, then PQ is in fact congruent to RS. And that's again by CPCTC.